And welcome. In today's video, we're going over the trigonometric integrals and kind of the process behind solving them. So the thing about trig integrals is they are, in all honesty, for the most part, going to be u substitution. The hard thing about them, however, is sometimes you have to use the Pythagorean identity, which, just let me write it out for you, which is going to be sine squared of x plus cosine squared of x is equal to 1. So this identity right here is going to become your best friends for solving these integrals. There's another set of identities that you may want to know, which are power reduction identities, but those will come up later on. For this first integral we have, we can notice that we have sine, which is derivative is cosine, and we also have cosine, which is derivative would be sine. So it kind of becomes unclear what we should do for a u substitution. So what we have to do is, whenever we choose either of these, we will find out they don't cancel just in the way they are. And there is not really a good way to get this cosine squared to cancel. So we're going to drop the power of this sine of x down to just being a 1. And the way we're going to do that is by saying that this is going to be the same thing as the integral of sine of x times by sine squared of x times by cosine squared of x dx. Now we can use the Pythagorean identity up here to solve for sine squared. So this now becomes the integral of sine of x times by 1 minus cosine squared of x times by cosine squared of x. And now we can easily use substitution because the derivative of cosine is just sine. So we're now going to say that this is the same thing as, we're going to say u is equal to cosine of x. So then the du must be sine of x dx. And I'm not going to solve for the differential dx in this problem. Now all we have to do is plug into the formula. So we now have the integral of 1 minus u squared times by u squared du. We can expand this out or distribute the u squared. So we get the integral of u squared minus u to the 4th du, which will then become u cubed times by, or divided by 3, minus u to the 5th divided by 3. Now we can sub in our u, which gives us cosine cubed divided by 3, minus cosine of x. Cosine of x to the 5th divided by 5. I've accidentally said over 3 over here, but that is okay. We all make mistakes, and always remember to add the constant of integration c. And that is our solution to this integral. For this next integral, we have to use a power reduction formula. In this case, we are going to use the formula cosine, and I'm just going to write this in white, cosine squared of u is equal to 1 plus 2, or cosine of 2u divided by 2, which we're just going to rewrite for our sake 1/2 plus 1/2 cosine of 2u. Now we're going to just plug this into our integral so that we get the integral of 1/2 plus 1/2 cosine of 2x in this case. This u is really just an x dx. Well, this is now a really simple integral. The integral of 1/2 is going to be x divided by 2. The integral of cosine of 2x, however, is going to be just sine of 2x times by 1/2 times by another 1/2, which would make that 1/4 sine of 2x plus the constant of integration c. And this right here is the solution to that integral. This next integral, I think, is a wide idea because sine here is an odd power. We're going to get sine in terms of cosine. So this becomes the integral of cosine to the 6th of y times by sine of y times by sine squared of y dy. Now we use the Pythagorean identity, which we already used to solve for sine in terms of cosines. So we now get the integral of cosine to the 6th of y times by 1 minus cosine squared of y times by sine of y dy. You want to know something interesting? I have made a mistake. Can you spot it? I can see it. The derivative of cosine is negative sine. So whenever we go to plug this in, we should just have a negative, which will make that a positive. So it becomes negative and then positive. So it becomes negative cosine of x, cosine cubed of x divided by 3 plus cosine to the 5th of x over 5 plus c. Sorry, that was a mistake, and I just realized I did that. So u here is once again going to be cosine because the derivative is sine. Our du is going to be negative sine of y dy. Well, this time let's not forget our negative. We're just going to plop it out front, and we're going to say that we're also going to multiply it. So we get negative the integral of u to the 6th times by 1 minus u squared du. Now we just have to expand this out. So we get the integral of u to the 6th minus u to the 8th. And remember that this is still like negative, the integral. Now we evaluate. So we get u to the 7th negative over 7 plus u to the 9th over 9 plus c. Now we just have to substitute back in for cosine. So we get negative cosine to the 7th of y divided by 7 plus cosine to the 9th of y divided by 9 plus c. Now we get to move on to tangents and secants. So the thing about tangents and secants is we use the same identity, we just have to divide it into something new. So we have sine squared here of x plus cosine squared of x is equal to 1. In order to get tangents, we are going to divide by cosine squared of x. This gives us tangent squared of x plus 1 is equal to secant squared of x. Similarly, if we divide by sine squared, which is something we will have to do for this specific integral, we would rather get 1 plus cotangent squared of x is equal to cosecant squared of x. Okay. Let's get into solving these integrals. You may notice that there isn't a tangent in this integral. But what is this integral equivalent to? This integral here is the same thing as, we'll just bring out one of the cosines that are being multiplied. So it's just going to become the integral of sine of x divided by secant, or not secant, cosine of x times by secant of x to the 4th, because this is really 1 over cosine to the 4th, or to the 5th, but we just pulled one of the cosines out over here. Now this expression right here is just the same thing as tangent of x. Now all we have to do is we are going to reduce this power by 2. So we are going to actually make this into the integral of tangent of x times by secant squared is the same thing as tangent squared of x plus 1 times by secant squared of x dx. Why did I leave behind the secant squared? The derivative of tangent of x is secant squared of x. So now we can use u substitution. So u is going to be tan of x. Or du is secant of x, secant squared of x dx. And even though I'm not going to show the step for solving the differential dx, that's what we're really doing and subbing that in. So this expression here becomes the integral of u times by u squared plus 1 times by du. Now we just have to distribute, so we get the integral of u cubed plus u du. This becomes, whenever we evaluate it, is going to be u to the 4th divided by 4 plus u squared divided by 2. What's u? U is tangent, so we get tangent to the 4th of x divided by 4 plus tangent squared of x divided by 2. And then always remember the constant of integration, c. All right, for this next integral here, I think this one's kind of fun because it requires you to think. So let's just think for a moment here. What is cosine squared of x equal to? Well, we can go back to our Pythagorean identity, and cosine squared is the same thing as 1 minus sine squared of x. So let's start there. That's going to be the first attempt we have at solving this. So this is going to become the integral of, we're going to call this sine of x divided by cosine of x times by 1 minus, and sorry, I accidentally wrote that out wrong. It should be cosine of x because it's a cotangent divided by sine of x. 1 minus sine squared of x dx. Well, let's expand this integral out. We're going to multiply this out. We're going to multiply the cotangent onto the 1 and the sine squared. So we still get the integral of cotangent of x dx, but we're also subtracting the integral of sines, or what this is really going to become here is this sine and this sine will cancel, giving us a sine times by a cosine dx. So the integral, so for this right integral, let's solve this one first. We're just going to say u is sine of x, and our du is going to be cosine of x dx. Really simple, right? This just becomes u. We raised the power by 1, so it becomes u squared, so it over 2. So it's going to be sine squared of x divided by 2. This integral, however, is something that not everyone knows. Not everyone will know off the top of their head what the integral of cotangent is. But it is actually an elementary function. It's just not as widely taught. The integral of cotangent, is the natural log of the absolute value of sine of x. Now we're just subtracting off sine squared of x and then adding on a constant of integration c. And that there is our solution to our integral. All right, now we have the integral of tangent cubed times by secant of x. The main issue with this expression here is whenever we take the derivative of tangent, there is not a secant squared. But do you know what we do have? If we take the derivative of secant, we have a secant and a tangent. But I think we want more secants here. So that's what we're going to try. We're going to use our Pythagorean identity to substitute tangents in for secants. So tangent squared of x is really the same thing as secant squared of x minus 1. So now we have the integral of tangent of x times by what we'll call tangent squared of x, which we're just calling secant squared of x minus 1, times by secant of x dx. We have a secant of x times by tangent of x, so that's probably our du. And we have secant. So the derivative of secant is secant times by tangent. So that gives us a good idea that our u is going to be secant of x. Our du in this case will be secant of x times by tangent of x dx. Well, we have the secant of x, we have the tangent of x, those will cancel, leaving behind just the du rather than the dx. So now we have the integral of u squared minus 1 du. Raise the power by 1, so we get u cubed divided by 3 minus u. Sub back in for secants. So now we have secant cubed divided by 3 of x minus secant of x plus c. And that, my friends, is the solution to that integral. For this next set of integrals, we have to use something known as the product identities. These identities are ways that we can kind of simplify two functions here, or two trig functions that are multiplied together, more specifically sine and cosine, and turn that into a simpler form for us to evaluate. What you may notice here is we can't use u substitution, because if we set u to be sine of x, there's a cosine of x, or there's a cosine of 1/2 of x, but there isn't a cosine of x, as thus we can't do u substitution for these. So we have to rely upon these product identities, which are stated above. Sine of a times by cosine of b is equal to 1/2 sine of a minus b plus sine of a plus b. Sine of a times by sine of b is equal to 1/2 times by cosine of a minus b minus cosine of a plus b. Cosine of a times by cosine of b is equal to 1/2 cosine of a minus b plus cosine of a plus b. I kind of sound like a broken record there. And so now we're just going to use these to evaluate this integral. And actually, this second integral is supposed to be a sine, because I did not want to do 2 sine times by cosines. So, to start out, we're going to turn this into the integral using this identity, 1/2 sine of a, or inside of brackets here, we're using this first one because we have a sine times by a cosine. So we get sine of x minus b, which is the argument for the cosine, which is 1/2 x, plus sine of a plus b, which is going to be x plus 1/2 x. Okay, we're going to pull this 1/2 out in front of the integral. So we get 1/2 times by the integral, and now let's simplify the signs. So we get sine of x of 1/2 of x plus sine of 3/2 of x dx. And now these are two separate integrals that we can evaluate whenever we're integrating. So whenever we integrate this, we can use u substitution for each of these. So we're going to say u, or actually, let's not. Let's try and do some math on our head here. So u in this case is going to be 1/2 x. So if you want to take the derivative the integral of this. Actually, yeah, let's break this down into u substitution just so I can help you understand this better. So we get the integral of sine of 1/2 of x dx. For this integral, you'd want to say u is equal to 1/2 of x. So then your du is going to be equal to 1/2 dx. We need to solve for the differential dx, so we get dx is equal to du. So kind of to put it simply, we know that this is going to be 2 times by whatever value is of this integral, which the integral of sine is negative cosine. So we get negative cosine, and we bring the 2 out front. That's going to cancel this 1/2 of 1/2 x. And now we can move on to the next portion of this integral. We now have 1/2, or really plus 1/2, the integral of sine of 3/2. Sine of 3/2 of x dx. Well, we know we're just going to bring this out front, but the 2 is going to really be canceled here. So we get 1/3 minus 1/3 cosine, because the integral of sine is just cosine, of 3/2 x plus the constant of integration c. And this is our solution to this integral. For this next integral, we're going to have to use the second product identity. So we get, this is going to be the same thing as the integral of 1/2 cosine of a minus b, which in this case a is going to be 2 pi x minus b, which is 5 pi x, minus cosine of 7 pi x, which I just already added them in my head, just to save some space here. We're then going to just simplify this side, which becomes a negative 3 pi x. We're going to pull this 1/2 out front, so this becomes 1/2 times by the integral of cosine of negative 3 pi x dx minus 1/2 cosine, the integral of cosine of 7 pi x dx. All right, so now we have these 2 separate integrals that are both really easy to evaluate. For this first integral, we're going to say u is going to be negative 3 pi x. Solving for the differential du, we get du is going to be negative 3 pi dx. Solving for dx, we get dx is going to be equal to du divided by negative 3 pi. Similarly, we're going to say q over here is going to be 7 pi x. So then our dq is going to be 7 pi dx. So dx is going to be dq divided by 7 pi. Now what we have to do is we just have to call this what this is. So this is now going to become 1 over, and we're going to just call this negative 1 over 6 pi times by the integral. This is now just the same thing as the integral of cosine of u, or, well, I want you to just imagine that I've already done all these steps. Okay, fine, I'll do the steps now. Should I? Yes, probably should. So we now have the integral, and I pulled out the du stuff out front. So this becomes cosine of u du minus 1 over 14 pi times by the integral of cosine of q dq. We just evaluate these integrals. The integral of cosine is sine, and same thing with that. So we just get -1, and we're going to put the cosines in the numerator here, or the sines. So we get sine of u. U is -3 pi x over 6 pi minus 1 over 14 pi, and put the sine in the numerator again. So we get sine of -3 pi, oh sorry, not 3 pi, 7 pi x. And always add the constant of integration c. And these are our solutions to these integrals. I hope that you found this video informative, and if you did, please like and subscribe.